All right, let's dive into a story that honestly feels like it's been pulled straight from science fiction. There's a giant, mysterious object from interstellar space that has just entered our solar system, and it seems to be playing by a whole different set of rules that we're used to.
And that's not just hype. That's a direct quote, the headline from a recent paper by astrophysicist Avi Loeb. It really sets the stage for what is shaping up to be a genuine cosmic mystery. The data we're getting on this object, named 3I Atlas, is making scientists everywhere rethink what we thought we knew about the things drifting in the dark between the stars.
So in this explainer, here's what we're going to do. We'll break down the latest news, then we're going to look at the bizarre data that has everyone scratching their heads. We'll figure out just how huge this thing really is, explore the two wild possibilities for what it could be, and finally look at what's next in this incredible cosmic investigation.
Okay, so let's get right into it. What exactly is 3I Atlas? Well, for starters, it's only the third interstellar object we have ever detected in human history. But here's the thing, unlike the first two, this one is making some serious waves because, frankly, it's behaving in a way that just doesn't make sense. And because of that, a whole global network of observatories is tracking its every move.
And I want you to understand, this wasn't just a couple of people looking through a telescope. The effort here has been absolutely immense. We're talking more than 4,000 separate measurements from 227 observatories all around the world, all focused on this one object over just a few months. All that data created an incredibly precise map of its path, and it's that precision that led to a stunning discovery.
And that brings us to the real heart of the mystery, something scientists are calling the missing push. See, as 3I Atlas gets closer to our sun, it heats up, and it starts venting gas and dust, just like a comet does. That escaping material should act like a tiny rocket engine, giving the object a little nudge, changing its path ever so slightly. But that push is missing.
Okay, so let's quickly break down that key idea, non-gravitational acceleration. It sounds complicated, but it's really not. It's just any change in an object's speed or direction that isn't caused by gravity. For a comet, the sun's heat turns its ice into jets of gas that shoot out into space. Think of it like letting the air rush out of a balloon. That escaping gas gives it a tiny but very measurable thrust. For comets, this is completely normal and expected.
So to see if this was happening, scientists followed a really clear three-step process. First, they used the incredible Webb Space Telescope to measure exactly how much stuff 3I Atlas was shedding, and it was a lot. About 150 kilograms every single second. Second, they calculated the push that amount of escaping gas should create. And third, they compared that prediction with the super precise actual path they had already measured. They were looking for that tiny little deviation from a purely gravity-driven path.
And this is the bombshell. The deviation they found was basically nothing. The push was less than 15 meters per day squared. That is an acceleration so tiny it's almost impossible to measure. So get this. It's blasting out 150 kilos of material every second, but it just refuses to budge. And there's really only one way that's possible. This object has to be unbelievably, mind-bogglingly massive.
The fact that this powerful outgassing had almost zero effect allowed scientists to do some math and calculate a minimum size and mass for 3I Atlas. And the numbers they came up with, well, they are just staggering.
Based on the data, the most conservative low-end estimate for its mass is over 33 billion tons. It's so massive that even having a force equal to a grown person being thrown off it every second wasn't enough to nudge it. That's like trying to change the course of an aircraft carrier by just blowing on it. It's just not going to happen.
And that incredible mass, it translates to a physical size that is hard to wrap your head around. We're talking about a solid object with a minimum diameter of over 5 kilometers, which is about 3 miles across. To put that in perspective, that's wider than the island of Manhattan. This isn't just some big space rock. It's a fluting mountain hurtling through our solar system.
Now, to really see what we're dealing with, you've got to compare it to our other interstellar visitors. You can see Oumuamua and Borisov there. They're barely even a sliver on this chart. 3I Atlas is in a completely different league. The analysis suggests it's somewhere between 1,000 and maybe even 100,000 times more massive than anything we've ever seen come from interstellar space.
And this is why it's such a genuine anomaly. Based on everything we know about how solar systems form and occasionally fling objects out into space, things this big should be incredibly rare. Statistically speaking, we should have detected something like 100,000 smaller Oumuamua-sized objects before we ever came across a giant like 3I Atlas. The fact that it's only our third visitor just defies all the odds. And that leads to a very, very big question.
So, what is this thing? If it's not supposed to be here, what could it be? Right now, the scientific community is really wrestling with two major possibilities. Is it just a 1 in a million natural object, a total cosmic fluke that breaks all our models? Or could it be something else?
Okay, let's look at the evidence like a case file. On the natural side, it could simply be an unbelievably massive, rare kind of comet. The stuff it's shedding, carbon dioxide, water ice, that's all pretty standard comet stuff. Its size, yeah, it's a huge statistical outlier, but it's not strictly impossible. But then you look at the technological side, and there are some really strange details. Its path is almost perfectly aligned with the plane of our solar system, a coincidence with about a 1 in 500 chance. And some telescope readings have detected nickel without any iron, which is really unusual in nature but pretty common in alloys we manufacture. Of course, the real smoking gun would be if this thing suddenly maneuvered on its own.
But wait, you might be thinking, what about all that gas and ice? Doesn't that prove it's a comet? Well, Avi Loeb makes a really interesting point here. He says we shouldn't judge a book by its cover. He argues that any object traveling through interstellar space for millions of years would naturally pick up a sort of frosting of common ices. So the carbon dioxide and water we see might just be the cover, a thin layer of cosmic debris hiding the true nature of the massive object underneath.
The good news is, we are not stuck just speculating forever. This cosmic detective story is far from over. In fact, we have some huge opportunities to gather more clues coming up right around the corner.
We actually have spacecraft already out there that are about to get a much closer look. On October 3, 2025, the amazing HiRISE camera on the Mars Reconnaissance Orbiter is going to get a much sharper image, which should help us nail down its exact size and shape. Then, in March of 2026, the Juno spacecraft, which is currently orbiting Jupiter, will have its own close encounter. Each of these flybys is a chance to replace all the speculation with cold, hard data.
You know, when you step back and think about it, whether 3I Atlas turns out to be natural or something else, its discovery is a game changer. It proves without a doubt that mountain-sized objects are cruising through the void between stars. And with all the new, powerful telescopes coming online soon, we are moving into an era where we might find these visitors not just once a decade, but maybe even once a month. We are opening a brand new window onto the entire galaxy.
So that's where we're left, with this profound and fascinating question. Is 3I Atlas just a cosmic fluke, a 1 in 100,000 natural giant that forces us to rewrite our textbooks? Or, just maybe, is it something more, a piece of technology from a distant civilization, making its silent, ancient passage through our neighborhood? Whatever the answer turns out to be, the search for it is going to teach us something truly extraordinary about our place in the universe.